When you press a drop of water between the two plates and press the plates, then water, which was initially a drop, so this is the drop. Now once you put these plates together, the drop will get squeezed. And so the drop will not remain this, but drop will spread sideways. And because of the small gap, the drop will become like this. What will be the shape of this drop now?
Cuboid.
No, it will spread in all directions, na?
Cylinder, sir.
Cylinder, a thin cylinder.
Yes, sir.
For the clean glass plate and water, the contact angle is 0 degree.
Yes, sir.
So there will be meniscus formed, which I have not drawn, but I'll draw it in the next diagram. Generally, when there is a solid which is in contact with a liquid, there is a meniscus. So we got solid, we have got air, and we have got liquid. When these three are in contact, we define a contact angle. For that, we draw the tangent to the liquid air surface, and we draw a tangent to the liquid solid. Liquid is common, liquid solid, liquid air. This angle is called contact angle. In case of water on a glass, unless otherwise given, you can assume the contact angle to be 0. 0 means this angle is 0. So this tangent and this tangent are same. So this tangent is also horizontal. For that purpose, the tangent here is horizontal, means pure semicircle. This is a semicircle. That's how the tangent is horizontal. So that's how the drop meniscus will be. Now the distance between the two plates is d. Now we have to find out the force of attraction between the two plates. We can define the force of attraction like this. Let's say there are two objects A and B. Let's say these are magnets. And they attract each other with 20 Newton force. So to pull them apart, do we need to apply slightly more than 20 or slightly less than 20?
Slightly more than 20, sir.
Yeah. So whatever we are applying to rip them apart, can we say that the attraction will be little less than that?
Yes, sir.
Okay. Now from the mass and density given, we can find out the volume. Volume of the water drop is this. Now that volume will be, as you say, this is a cylinder of some radius r, and this distance is d. So we can say that pi r square into d is mass by rho. From here we get the radius as m by rho d pi. This is what is the radius of this thing formed. Now there are multiple ways to do this question. Whenever we go from concave side to convex side or convex side to concave side, the pressure changes. The change in pressure, or the we can say P concave minus P convex, sigma into 1 by R1 minus plus 1 by R2. Do you know this formula?
Yes, sir.
In case of a sphere, R1 and R2 are same. Do you know this? In case of a sphere or spherical surface, R1 and R2 are same. What are R1 and R2? Can you tell me? R1 and R2 are the principal radius of curvatures.
Yes,
In
sir.
case of a cylinder, can you tell me R1 and R2 values?
R1 is radius of cylinder, sir. R2 is infinity, sir.
Correct. Now here also we need to check. When we are going like this, which is concave side? The air or the liquid?
Air, sir.
Air. So if the air pressure is P naught, what will be the liquid pressure if you take only this surface?
P naught minus sigma by R, sir.
And R, can we write it as d by 2 if it is a pure semicircle in case of a zero contact angle?
Yes, sir.
Now there is one more thing. Either you can travel like this on the surface or you can travel like this on the surface. If you travel like this on the surface, which is the concave side, the liquid or the air?
Can you repeat again the question, sir?
If you are going like this along the surface, imagine like a cylinder.
Yes, sir.
If you're going like this on the surface, the cylinder inside is concave or cylinder outside is concave? Like for this kind of curveness.
Inside is concave, sir.
So are you understanding that when you are going along this kind of curveness, the liquid is in the concave side?
Yes, sir.
So what will be the total pressure inside the liquid? Can you tell me now?
P naught plus sigma by R, sir.
So can we say this is the overall pressure?
Yes, sir.
Considering both the surfaces and both the radius, one radius is d by 2 and one radius is r.
Yes, sir.
And r you can calculate from here. Now, that's the liquid pressure. Let's talk about one of the plates. This side there is atmosphere. This side also there is atmosphere. So P naught cancels out. However, here there is P naught and here there is. So which pressure will be more? The P naught one or the P naught minus sigma by D2 plus sigma by R?
P naught will be more, sir.
Correct. So P naught will be more means, and by the way, this area in which this liquid is present depends on the R. Depends on the R.
Yes, sir.
So what is the net unbalanced pressure force? Can you tell me?
Sigma by d by 2 minus sigma by R into the area.
And this pressure force overall will be on this upper plate, down or up?
Down, sir.
Very nice. It's like this pressure force is trying to push these two together. That is what is causing the attraction. Because the atmosphere has to dominate. The atmosphere will dominate and press these two clouds together. So we feel that we will get a feeling that as if these are getting attracted. To overcome that, we also need to apply the same unbalanced force like this. And whatever force we have to apply, slightly less than that will be the attraction. And we have to apply same thing only now. So the attraction between the plates can be written as sigma by d by 2 minus sigma by r into pi r square. This we can call it as the attraction. Are you understanding this?
Yes, sir.
Ah, it's the atmospheric pressure force which is pushing them together because between them is low pressure, but we feel that they themselves are attracting. It is the atmosphere which is pushing them. R is R square is m divided by pi rho d, m by pi rho d. is R square. I'll write it as. Now, out of these two terms, which term you think will be dominating?
Sigma by d by 2.
Oh, pi got cancelled, huh? Two sigma m by rho d square. Is this question clear?
Yes, sir.